Okay. Second method, when we have one linear measurement and one angular measurement, means one chain and one theodolite. Okay, so that's it. How can we set out the curve with these equipments we have? So it is also known as Rankine's method. Rankine's method. Okay, Rankine's method. How we will set out this by Rankine method? Just see it. Okay, just to see it. So by this, first I will give assumptions. So it will useful accuracy greater than linear measurement. Linear measurements 2, but less than theodolite methods. Not a theodolite, two theodolite methods. Okay, so and also it will mainly uses railway tracks. Why railway tracks? Railway track has mostly flat curve. What is mean by flat curve? Railway curve. What is mean by flat curve? Flat curve means a radius is too large. The curvature is very small. If you take it, this is a large curve or bulk curve. If it is took a flat curve. If it is a flat curve, what is the radius? Radius is too large. If it is a bulk curve, radius is very small compared with this. Are understood? It's a flat curve. Flat curve. So flat curves are used mostly for railway tracks because you know it. Rail doesn't take easy to take it curve turn. So we have to provide a long length at the curve. Okay. So in a buses or autos or bikes, you can easily place a bulk curve. In a railway tracks, we have to use flat curves. See, in this flat curve, and also I will give in this flat curve, long chord is like this. In the bulk curve, long chord is this. If you just see it in a flat curve, almost long chord is equal to the length of the curve. Almost. In a bulk curve, long chord doesn't is equal to the length of the curve. So it has a large gap. It will go more probably equal. So that is our third assumption. Chord length or long chord length is equal to the length of the curve. Length of the curve. That is another assumption. So if you put this assumption, compulsory it will satisfy only the flat curve, not a bulk curve. Are understood? So that's why Rankine's method is used only for the flat curves. It will used for this curve also, but it not give exact curve. It doesn't give exact. Okay, so many approximations are there, so just deviate from original curve. Small deviations are there. So okay, are understood? So that is the Rankine's curve assumption. So now I will took the example. If you see, if you also observe one thing, you have to observe one thing. If it is a long flat curve, the angle of deviation is small. Compared if it is a bulk curve, the angle of deviation is large. Are understood? That is also one thing. That's why I give very small. Small. And also we have to draw a tangent, no? So 90 degrees of tangent. So what is it? This is 90 degrees, or probably, yes, most probably, I think. Okay, so sorry, it will not give exact much. If you take in this only, we can found it. That's the point, huh? Otherwise, we'll draw sketch, pencil sketch. It will not good. Okay, see, this is the angle of deviation. This is the point of curvature, T1. This is the point of tangency, T2. We have to set up the curve. How can we set the curve? How can we set the curve? Okay, that's it. That is our question. First, make it. First, put a theodolite at T1. So, first, put a theodolite at T1 and makes 0 towards V. V is apex point, V. Okay, make 0 towards V. That's it now. So then make an angle of delta something. How can we choose delta? I will later. Make a delta towards right side. That's right side, no? Towards right, and making line of sight. Just to make a line of sight. So how can? Very approximation. Okay, that is a line of sight. That is delta 1, or so I don't think that's delta 1. Okay, delta 1. So next, what is the procedure? Next, seeds. Seed is, so seed is, if the same curve, see the same curve delta 1, just draw an angle, just draw from this line, from this line. This is no need to draw, just an idea. No need to draw, just idea. See it. It will take two angle, two delta. Here, it is delta 1. This is delta 2. Sir, how it is? I again explain a proof. In this small manner, in this manner. Okay. See, we already discussed this is a tangent. Okay, this is a tangent. Are understood? So this is a curve. This is a curve. You're just making an angle of alpha. Alpha. You just add those two. Add those. How it is 2 alpha at center. This is the center, na? Center of the circle. How it is? This just this point. See, this point is. You just make it as this point is on the surface of the circle. How it is? It makes it 2 alpha. I will explain. I will explain. See, it is. No, that's very small. You can't understand in this small. I will explain. I will write in some other place. Okay, I will. It is a tangent. Okay, it is a tangent. It is a circle. It is a circle. You just make an. Okay, I will make a large. You will make a large. Okay, so see, it is. This is alpha. Okay, see, I said this is a 2 alpha. How it, sir? How it? Sir, yesterday you thought it's a alternative segment theorem. No, alternative segment theorem is making a triangle at the surface of this triangle, at the surface of the seeds, at the surfaces of the circle. It is a center. Now it's a center. See, these are the surface. Surface, surface, surface. There is no center here. I understood? Alternative segment theorem. It is alpha. This is 12. This is also alpha. I said na. So that is the only surfaces. Now different. Now it is a center. How, sir? See, it is. This is all R na. This is also R. That is the radius of the circle. Radius of the circle. If you see it, these two are same. Those two sides are same. It is a triangle. Just observe. This is a triangle. Are understood? This is a one triangle. These two are and are. These two are same sides. That means this angle and this angle is also same. Are understood? This angle is also same. Just and observe. This is a tangent with respect to this point, this line. Are understood? So now this total is 90. This total is 90. Are understood? This total is 90. Okay, that's total is 90. This, see, it is, this is alpha. I said this is alpha. Okay, so what it make? What is this angle? What is this angle? This is 90 minus alpha. Antena? 90 minus alpha. What is this? This triangle. This is what? This is a triangle, na? This is a triangle. So this is alpha. So remaining is what? 90 minus alpha. Understood? So if it is 90 minus alpha, this is also comes 90 minus alpha, because it is both sides are two isosceles triangle. These two sides are equal. These two sides are equal. Understood? These two sides are equal. This angle and this angle are same. We don't know. But this is a tangent. If you feel this is a tangent, so compulsory this total is 90. So remaining is 90 minus alpha. Okay, that's it. If you see, this is a total triangle. So total angles inside of the triangle is how much? 180. So 90 minus alpha, 90 minus alpha, we don't know this angle. We add something x is equal to 180. So what is the value? 180 minus 2 alpha plus x equal to 180. So 180, 180 cancel, x is equal to 2 alpha. That's it, na? So that's it. That's it. I don't feel it is a circular theorem, but I will explain it. Okay. So this is a 2 alpha. I don't want to. So sir, if you maintain a 2 alpha, we need another third light. No, no. You don't need any third light and you don't need any drawing or line of making. No. Just I will explain. Okay. See, it is. If it is a alpha, this is 2 alpha. So just make it. If it is a real, that's see this is going to be a curve. Are understood? This is going to be a curve. This is a circle point, na? So this is going to be a curve like this. So what is the curve length? What is the curve length? I'm asking, this is the curve length. See it is, this is a tangent, this is a curve, na? Curve. So are you just making an angle of 2 alpha? For the 2 alpha, what is the length of this line? What is the length of that curve? This is, what is the length of that curve? What is the length of that curve? For just two angle making. So total angle, you know it. So total circumference is 2 pi r. You know it. For just only up to 2 alpha, how much is the length of the line? How much is the length of the line? How much? Just see it is for a 2 pi r. 2 pi r is 360 degrees. For 360 degrees, 2 pi r. For now, only 2 pi. For now, only 2 pi. So how much it is? How much it is? How much it is? How much it is? C length. So multiply. So 2 pi multiply 2 pi r divided by 360 is equal to the length of the curve. Understood? Just this length of the curve. Length of the curve. Okay, I understood? Just you know it. But I feel that I am once again said that this is the length of the curve. But I said that in the assumption, chord length is equal to the length of the curve. Chord length. So I am making an assumption just in adding those two chord. It is a flat curve, no need to. So flat curve almost equal. I just giving the bulk example. So bulk curve I took example to understand what is the chord length, what is the length of the curve. Okay, I understood. So see it is. So I just feel that this is a chord length. Okay, I just feel that this is a chord length. So are you find out easily chord length? Can you find out? Can you find out the chord length? Easily find out the chord length. If you take some alpha, something 2 degree, 1 degree, 2 degree, 3 degree, 4 degree. Okay. So if you know the chord length, if you know the angle, you can easily find out the chord length. Understood? Otherwise, some. So how to start the procedure is, see it. First you fix the chord length. Understood? So sir, why sir chord length? But we have a tape. See, not a tape. We have a tape or chain. So what is the tape length or chain length? Mostly 20 meters or 30 meters. Na? So first you fix the chord length 30 meters. Sir, once again I said that chord length is equal to the length of the curve. Sir, both are not equal. I make an assumption both are equal because very small difference, 30.001 like this. Okay. So make a C. Find out alpha. Make a C and fix the alpha. So how it's 360 C divided by, so what is this? So 266 divided by 4 pi r. And then so like this, it is 90 C by pi r. Okay, in radians it will come like in radians. You can easily change it with radians to degree. I already said 2 pi r radians equal to 360 degrees. 2 pi r radians is 360 degrees. You can easily convert to the radians to the degrees. Okay, how? I already said how. 2 pi radians 360 degrees. So you can easily change 1 radian how much degree. We discussed in triangle surveying 1 how to change radians to degrees to minutes to second. Okay, so that's it. So this is the maintain. See it is. What is the procedure is, see it is. Just make C value. C is mean by 20 meter or 30 meters. Just take it. Based on that, you just fix the alpha. See, angle. You just making the angle delta. Are understood? So this is the value. So now you see what is the procedure. You just making an angle of alpha 1 this high. So towards this side. And also it making a 2 alpha at center. No need to draw a line. What we do, just we have to identify this point. We have to identify it. So if you have a theodolite at the center, you have to easily identify it. Sir, but we don't have theodolite. So how can we identify this point? So we just making, just see it, we just making, I eliminate this, I eliminate this. Okay, so I eliminate this. Okay, I just making elimination. So how can you identify that point? So we already see it, based on that c, based on that c we took 20 meters or 30 meters, we can fix that alpha, say delta, anything we can fix the delta. So by this delta, taken delta and we make an theodolite to some delta angle. So okay, now we have to identify that point. How can we identify? So we already know c value, we already know the c value. C is 20 meter or 30 meter, so that is the length of the curve. Sir, it is a chart, I already said assumption. So this is the length of the curve. So okay, so how can you do? Just put a one tape here, one man fix a tape and fix 0 at this location, at this location, and took 30 meters, 30 meters toward the line of sight, toward the sign of the sight. 30-meter change, just one man go and he's searching, and another man is seeing the theodolite. So those point of contact, he is looking forward. Okay, some other man is putting 0 here and he went through this direction and searching somewhere here, searching somewhere here na? He is searching like this. So just seeing the theodolite and you can order the man, okay, fix it this point. So okay, this is 30 meters, 30 or 20 meters. So sir, that is the chart, sir, that is not a length of the curve, I said assumption. So fix that point, hold it, fix that point, hold it, that's it, enough. That is the one point. Understood? That is the one point. That is the one point. I said that that is the first point. That is the first point. So okay na? That is the first point. So because why it is the first point? It makes 2 alpha at the center. So that's why we calculate the length of the curve. That's why we calculate the length of the curve. Understood? We calculate the length of the curve. Based on that, we assumption length of the curve is equal to length of the chart. So from this point to this point, how much it is? 30 meter or 20 meter? What is it? Okay. Based on that only we calculated the angle. Sir, for 30 meter chain length, what is the making of angle? So you can easily calculate it by this. See it based on R also. If it is 30 meters, based on the R, we can easily calculate it 5. Okay, are understood? That's it. Later, next point. So how can we fix? So go to the next point. So next point, see it is from this point. From this point, you change another. You can. So you can see another took another delta. Another delta. Same delta value. So from this point, first second point. Okay. From this second point, you took another delta. Another delta. Another delta. Once again. So this delta, na, this is going to be another delta. Another delta. So and again see it is. So and again see from this point. See from this point to. So another point. Somewhere here. Somewhere I said somewhere here. Somewhere here. Another point. What is the angle making? Same, this is R, this is R, same thing. So this is also making 2 delta. If you say if it is delta 1, if it is something you took delta 2 based on your chain length. Sir, we have a 30 meter chain, so fix 30 meters. Okay, 30 meters, okay. If not available a 30 meter, something, those are irregularity. It is a 100 meters. First is 30 meters, next is 30 meters, next 30 meters, later 10 meters. Right? So you can't have every segment is 30 meters. Some segment is 10 meters, some segment is at center. You can may change it. So that's why based on those sources, I said I changed some angle. Okay. If it is delta 2, so this is also 2 delta 2. If it is delta 1, this is 2 delta 1. Okay, this is a 2 delta 1. Understood? Same thing based on this delta 2. Based on what is delta 2? Delta 2 took the from this 10. What is the chord length? So based on the chord length, you fix that delta 2. So you took delta 2 from here. From here you took delta 2. And later what is the chord length? C2. C2 no? So if it is delta 2, same 90, what is your chord length? If you fix something, this is a 30 meters, you fix that. This is a 10 meters. This is 10 meters, you fix the delta 2. So you come from this point to delta 2 angle. Just make it delta 2 angle. It will make 2 delta 2 at center. And you just took same thing, same observation, just place 1, 0 at here, at the linear measurement tape. 0 at here and go through this and searching somewhere, and by the looking of the theodolite, you can fix this point. Understood? So based on, so if you see it, what is the deflection angle of this point? You see it is, what is the deflection point of this? This is first is delta 1. So from this point, what is the deflection? Total deflection. Total deflection is what? So up to this level, this is a delta 1. Are understood? So now it is delta 2. So total is what? Total is total delta 1 plus delta 2 na? From the point of contact. See, point of the curvature. So up to this you can make it the delta 1. Later from this direction to next direction you make a delta 2. Are understood? So total deviation is delta 1 plus delta 2. Okay. So that's why something, okay, I will explain later. Okay. So next once again, from this point to you make another angle. You make another angle. So maybe some other chart length. You took based on that your field requirements. You took some other delta 3, some other C2. First C1 is 30 something, C2 is that 10. Most probably we will use a same. If you took 30, we will took 30, 30, 30. But some other places, maybe I said that if it is a total length is 100, how can you divide by 30? So maybe one or two sides, one or two locations, we have it to different chord lengths. We have to make it. Okay. So, but in the process, I simply gave different chord lengths. Later it will be easy because we took a same chord length. Okay. So if you took some other C3, so based on that C3, we have to fix delta 3. So once again, making an angle of delta 3 here. So like this, okay, like this, okay, this direction. So and also what is the chord length? You know it from this point to chord length. Fix it, chord length, and no need to draw. Just I said that I will give what is the meaning of this chord. It will makes again 2W3. Okay, understood? So that's it. Now. Based on the chord length, you fix it from this point 0 to chord length. Find out the point. So okay, are understood? And also if you see the angle of deviation from this point to this point is how much? Angle of deviation is total is delta 1 plus delta 2 plus delta 3. Are understood? So that's it. You make it every point. Later what do you think? Later you just join those points. Later you just join those points. You will get a curve. Are understood? You just making the point. That's it. That's it. That is the procedure. It has one approximation, that is chord length we taken as the length of the joint. So if you see it, I already understand actual length of the curve is this is, but we took that chord length. Is the length of the curve. It has a small approximation, but if you do a flat curve, if you do this experiment on a flat curve, there are more over easy. See, more over equal. Both are more over equal. That's why I took a small approximation, small assumption. Okay, are understood? So I just calculated length of the curve, but I took from tape to from this point to this point. Are understood? From this point to this point, I just making by a tape or chain by just doing like this. But actually, that is the length of the curve. Okay, that is the only. If you understand, that's it. That's it. This is over. Are understood? That's why something assumption is not an assumption in a calculation. First one is delta 1, it called as a some delta 1. This is delta. If it is a triangle, this is also delta 1. Second one is delta 1 plus delta 2, it will come like delta 1 plus delta 2. This is not, this is called delta 1 plus delta 2. What is this? This is delta 2, I assume. This angle is delta 2, angle of deviation from the point of curvature. So what is this? This is delta 2 plus delta 3. Understood? Delta 2 is, this is delta 2. So later delta n is delta n minus 1 delta n. Understood? So by this angle, no need of these remaining formulas, no need. But just in some textbooks they differ like this. First one is delta, second one is angle delta 1 plus delta 2. This is something, two different names are there, I didn't remember, that's why I pronounced both are delta. Okay, so in delta 3, delta 2 plus some delta 3. Okay, small delta 3. Okay, and then angle of deviation from the center. But what is the use of, sir? No use at all. We will do a problem. Okay, that's it. That is the Rankine's method. So okay, I will do a problem. So that is the procedure. So you can write sentence one by one by sentence based on this calculations. You can write it. I already explained. You can write it by your simple words. No need to follow some textbook. What is the point number 1, point number 2? No, sir. Please, sir, don't copy at all. So I explained the procedure. So you can write in your words. Okay, that's it. I will do a problem. No problem at all. Okay, so that's it. See, two tangents intersect at the chain edge 1190 meters. The deflection angle is 36. See, 36. 36 is very small deflection angle. 36 is very small. The deflection angle is very small. So by looking, you can easily find out that is a flat curve. By the flat curve only, its angle of deviation is very, very small. So these are the observations. They didn't write, they didn't find out in any textbooks or any something. So that is by observation. Okay. So 36. Calculate all the data necessary for setting out a curve with a radius of 300 meters by Rankine's method. It can also called by deflection angle method. Deflection angle method also. Deflection angle, just one deflection angle, that is alpha 1, alpha 2, alpha 3. So I can write it as a deflection angle method. Okay, just a deflection angle method. So okay, so chain length available is 30 meters. So in textbook it called a peg length. What is a peg length? Peg is what? Peg is just a marker. You already see in surveying what is a peg. Peg length is one peg to another peg. What is the length difference? that is a 30 meters. So how can we fix the peg length? Based on the availability of the chain only. Availability of the chain only, na? So it's called peg length. So difference, so distance between the pegs is called peg length. What is a peg? Peg is just a wooden stool, not a stool, wooden peg. Okay, that's the peg length. So see it is. So at a chain has point of. So I will draw once again curve. So I will make it as a very short. 36 is very small. But if you draw very small, you can't understand. That's my problem. Okay. Okay. That's it. And you have to draw a tangent. So what is the point of contact? Somewhere here where it is. It will come like this. Okay, something like this. Okay, see what he given. Total, this is called 36. So this is also 36. You know it, and the tangents of intersection at 1190. So he said that this is 1190 meters. 1190 meters. So where do we have to start? Start from T1, point of curvature to point of tangency. So first we have to find out the tangent length. Okay, and he gave R is 300 meters. So R is 300 meters. So first we will find out the tangent length. So what is the tangent length? T is, we already solved so many times, tan 5 by 2. So what is the tangent length? 300 tan 36 by 2. It is called 97.48 meters. So what is that point? So this is 1190. What is that point? So this point is 1092.52. Na? If it is 97.48. Okay. So this is the point of tangency. Understood? This is okay. That's it. And also we can easily find out the length of the curve. What is the length of the curve? What is the length of the curve? Length of the curve entappa. So just is 36 degrees. For 2 pi r, for 2 pi r is 360. For 36, how much is? By 10 times, na? Just 10 times. 10 times. So divide by 10 times. So how it is? 2 pi r by 10. So what is that? What is the value? Length of the curve is as? How much is? What is the value here? It is a 188.5 meters. Okay, 188.5 meters. So it is a 10092.52. This is the point of just adding the 1092.52 plus 188.50. So what is the chainage point? 1281.02 meters. So if you go by like this direction, if you go by this direction, so from this 100.52, this length is 188.50. So this is point is chainage is 1281.02 meters. By our convenience, sir, it is 1190. So this point is also same 1092. No, we are making the curve, so that way we should some procedure, should we place some procedure, we follow it. So first we have to find out this point t1. So later from this we originated, we start the procedure from t1 na? So everything, so that's why we make some convenience, so our understanding, based on that we should start the procedure. So that's why this is a point of 1280. So I will delete this curve, later I will draw curve. So okay, later I draw. How can we draw the curve? That is the question. Okay, that's it na? If you see it, this is the length of the curve. What is the length of the curve? What is the length of the curve? 188.50. So we divide this 188.50 into how many parts? So sir, peg length is what? 30 meters. So just peg length is 30 meters. So divide by 30 meters, how many times? Almost 6 point something na? 6 point something. 6 point something. So how can we divide? That's why I said delta 1, delta 2, delta 3, something different angles. So how can we fix that? How many intervals are we are making? So based on that interval, based on that peg length or chart length, we are decided the angle of deviation. Understood now? So based on the chart length we fix only, not only 30. If you make 30, something is missing. So how can we fix that? So just very small thing, just see it. So starting point is, just see it, 10092. So ending point is 1281.02 na? So 1281.02. Remember, middle length is 188. No problem. 188.0. So I will make like this. See it is, first I will took, so this is a 1092 na. First one I make it is as a 17.48 meters. So first one is 17.48 meters. Later I will took 30, 30, 30, 3, 4 and 5. So where will reach? So 10,092.5 to 17.48 means what will come? 11, exactly 1100 na? 11, 10. 11, 10 na? So 11, 10. So it will come 11, 10. So this will come 1140, 1170. It's okay. So 1200, 1230, 1260. So last one is 21.02. So 12180.02. So I will divide that peg length is like this. Not I am not interested to take everything is a 30, or I will took 30 30 30, last I will took something I won't interested to. Okay, so I will divide like this. I will divide like this. Okay, understood? I will divide like this. So this is, don't follow what I said. So if you want interested, you take something different intervals. But he said that peg interval is 30. So that means he has an availability of 30 meter chain only. Don't take more than 30. If you took less than 30, no problem, because we have a chain length of 30. We have an availability. So okay, you can divide whatever you are interested. No problem at all. But my interest, I took this. Okay, I will divide this peg length. Okay, that's it. So first one is C. I will take it 1748 meters. So, chart length. Sir, this is not a chart length. This is the length of the curve. So I said, once again, assumption. I'm making an assumption that the chart length is equal to the length of the chair. So I will make C is equal to 11. So based on that C, I will find out the angle. So what is the angle? What is the angle? So I will set that 90C divided by pi r. Are understood? 90C divided by pi r. Arika? So what is the value? So what is that value? So change it. It will come like, it will come to into the radians. So you have to change any angles. What is that angle? This angle is 1 degree 40 minutes 09 seconds. It will come into radians upper. It will come into radians. You have to change into a degrees. 1 degree 0.40 minutes 0.9 seconds. So next C1 is this is C2 30 meters. So for 30 meters, what is the value? So this is 2 degree 51 minutes 53 seconds. So C2, C3, C3, C4, C5, C6, everything is equal. Are understood? What is the C7? So this is a delta 2 to delta 3, 4, 5, 6. C7 is what? C7 is, again I will took 21.0. So delta 7 is 2 degrees 0 minutes 26 seconds. That's it, no? That's it. So these are the angles we already know. So what is the procedure? First seed, first took delta 1. This is the delta 1. First chord length of 17.48. 1 degree. Seeds 1 degree. Very, very small. So 1 degree. But I won't give it's a 1 degree. If I put a 1 degree, you can't imagine or you can't understand. I will just like this. Put like this. Okay. So I will draw 1 degree curve. Line of sight. 1 degree line of sight. Just is a delta 1. 1 degree. Okay, so what we'll do, what we have to identify the point on the curve. So what is the point on the curve? How can we find out? So just placing chain here 0, chain here 0, and what is the chart length? Chart length is what? So 17.48. Understood? So 17.48, just to make it from 0 to 17.48. So somewhere identify this 17.48. so just make it. So make it now. That's it. Later next, from this point to here again. So second angle is what is delta 2. Delta 2 is 2 degrees 51 minutes. So okay na? So 2 degrees 51 minutes. Just to make it 2 degrees 51 minutes. Okay, understood? So I will again draw. Sorry. Two degree. This is delta 2. Again 2 degree. 2 degrees. And also chart length is what? Chart length is what? 30 meters. So make it. So put chain here 0 and 30 meters. Go to this 30 meters. Just by looking into the theodolite and someone is going around those spots, and you just ordered that fellow, that's what is exactly coinciding with the line of sight. Just order, okay, place it 30 meters, sir. That's it. Like this you can go now. It's again. So it is not exactly 7 parts. If you go to with 7 parts, we have to make it angle 1. If you make it angle 1, you can't observe. So I can't draw. That's first thing. I can't draw. That's why I will. Otherwise, it's a 7 parts. Already 2 parts I will reach up to the center. So it is not accurate, but it's the procedure. Okay. If you draw a diagram, simple diagram, you can easily understand. Not an exactly, but you can understand. Without a diagram, without diagrams in textbooks, without diagrams, they will write so many formulas and calculations, but no one understand what is this, what is this. If you just draw a simple diagram, you can feel it, so you can make it. Okay, that is my intention. Okay, not an exactly replica of the problem. So next, you can make it as a mala once again 2 degrees na. So once again, what is that? 2 degrees up to delta 6. Up to delta 6, it is a 2 degree once again. Okay, so and again chain length is something, take this. So take its length. Okay, if you observe it, so delta 1 is okay. Delta 2, how much angle from this point? So delta 3 from this deviation angle. See, it's deviation angle. What is first one is, second one is delta 1 plus delta 2, that is called delta 2. Third one is delta 1 plus delta 2 plus delta 3, that is delta 3. And also called this delta 2 plus delta 3. Like this. Up to 1 to end. End is just looking at the up to opposite point. Up to this location. Are understood? What is delta n? How many what is delta n? Delta n is last. So last point will reach like this up to this reach point. Okay, up to this reach point. Up to reach point means what? Exactly what is the length? I understood. What is exactly delta n? Delta n minus 1 plus delta n small n. Okay, what is delta n? Total angle of deviation. How much is? Total angle of deviation will come like this angle. What is this angle? What is that angle? Understood anyone? What is that angle? That angle is I by 2. Understood? This is a 5. This is a 5. So what is this value? 180 minus 5. So these two are equal compulsory because these two tangents are equal. Na? So others, if it is x, x plus 180 minus 5 is equal to 180. Okay. So see it is 180 cancel. 2x is equal to 5. So x is equal to 5 by 2. So this total deviation angle is come like 5 by 2. This is also 5 by 2. So total delta n comes like 5 by 2. That is also one observation. Okay, no need of observations, you feel it. Okay, so once you find out those points, just add those curve by a simple okay, by a simple mechanism, otherwise I will come to the red mark. By a simple line. That's it, na? That's it. That is the procedure of Rankine's method. Understood? That is the procedure of Rankine's method. So based on the deflection angles, understood? Based on the deflection angles, we can identify the points on the curvature, points on the surface of the curve. So we have a biggest assumption is chord length is equal to the length of the curve. So that is the biggest assumption. So it will be work out only with the flat curves, not a bulk curve. So where will we use the flat curves? Flat curves will be used mostly in the railway networks. That is the summary of this course. Okay, summary of today class. What is the summary? That is the summary. Are understood? So that's it. You can easily find out this delta 1, delta 2, delta n. That's a CN. If you want to make out a tabular form, so just is peg number 1. So chain is, you can easily find out the chain is. So chord length and tangential angle. So deflection angle, total deflection angle. So peg 1, as exactly peg 1 is what? So peg 1 comes at where? This point. So peg 1 comes to which point? 11, 10. Okay. So peg 1, 11, 10, 0. Chord length is 17.48. Tangential angle is 1 degree 49 minutes. Deflection angle is also same thing. Deflection angle means, tangential angle means from the points, these points, how much tangential variation. Deflection angle means from the point of curvature. From the point of curvature, we calculate the deflection angle with. Total deflection angle comes like 5 by 2. Okay, so that's it. That's the first. Second, so what is the peg length? So 1140. Chord length 30. Deflection angle 2 degree 51.53. So total deflection angle. So 1, 2. You don't add just deflection angle. Delta 1 plus delta 2. What is come? It will come like 2 degree. So not a 2 degree. 2 plus 3, 4. 3 plus 4, 4. 4 degrees to 32 minutes 02 seconds. So go with 33. Go with 3. So 1170. 1170. Again 30. Again 251, 53. So you add it. If you add it, it will come like 723, 55. Okay. So go with 4, 5, 6. Same thing. This will same. So it will come like 10 degree 15 minutes 48 seconds. So it will 13 degrees 17 minutes 41 seconds. So it will come like 15 degrees 59 minutes 34 seconds. So last one is peg length is it will reach to the another point. What is the another point is? Another point chain edge is where? 1281.02. Understood? 1281.02. Peak length is not the same. Peak length is what? I took 21.02. 21.02. Chain edge is C. Tangential angle is 2 degree 01. 2 degree 01 minutes 26 seconds. It will reach. Deflection angle it will reach. So somewhere missing 4, 7, 1, 4, 7, 10, 13, 15. It will reach 18. 18 degrees 0 minutes 0 seconds. So what is that 18? 18 is off. See, this is 36. So what is this? 18. So total deviation angle is 18. Understood? So that's it. It will reach to 18. That is the tabular form. You make it a tabular form, or you identify the points on the surface of the curve. So you join by the simple curve. That's it. No? That's it. The Rankine curve is over. Those are the setting out of the curves are over. So the only remaining class is in the chapter is compound curve. Those parts. Setting out of the compound curve is not in our syllabus. Not in our syllabus. So no need to discuss. So only one class is there. For the next